Guys, in reading problem number 1, it says, if a ball is dropped from a height of 18 feet, the function 15 times 0.05x gives the height of feet of each bounce, where x is the bounce number. So that's the bounce number. What will be the height of the ninth bounce to the nearest tenth of a foot? So what they want us to do is, they want us to take this formula right here, this formula, 15 times 0.075, or excuse me, not 0.075, 0.75x, and plug in the number 9. Okay, they've already done all this prep work for us. They've already told us that this ball is bouncing. It bounces to a height, then it bounces to a lower height, then it bounces to a lower height, then a lower height. So this is an exponential decay. They've already set up for us that each time it must come back at 25% of its bounce. As somebody asked about the basketball game last night, this happens. This very thing happens at the beginning of every basketball game. Referee will walk over and he'll get a ball off the rack and he'll hold it like this right here, and he'll hold it up like that, and he'll drop it, and he'll hold his elbow out like that, and the ball ought to come close to his elbow. If the ref is 6 foot high, a basketball, when you drop it from a height, ought to come up 2/3 of the height. So if he's 6 foot high, he throws it up, he's going to hold his elbow about, and it should be about close to about what 4 feet is, because most guys are about 6 foot tall. And so you hold it up there and you drop it, and he'll hold it up, and he'll come up there and he'll go, okay, yeah, that's a good ball. We'll throw it in, and we'll use that ball as a game ball. Okay. This particular problem, in this situation, if it's dropped from 18 feet, it must come up 25% of that. 25% as a decimal is what? As a decimal is what? 0.25. So they've moved the decimal. They've moved the decimal over for us and made it 1 minus 0.75 is, or 1 minus 0.25 is 0.75. So that's where that formula comes from. So now, guys, it's just a matter of plugging the numbers into the equation here. So it's 15 times 0.75 to the 9th. And the directions say round it off to the nearest tenth. So this thing it's going to be approximately 1.1 feet. Again, I know where to round this off at by looking at that 2. When you round something off to the nearest tenth, guys, when you round to the nearest tenth, you look at the nearest hundredth. That's a 2. So it means stay this. Now, same question. Had it asked us to round this off to the nearest hundredth, then we would have looked at the thousandths. And the thousandths number is 6. So what would that have rounded off to? 1.13 if it was to the nearest thousandths. But this problem asks for the nearest tenths. So we just plug it in. Again, guys, at first, a lot of these are going to set up and they're going to solve it out for us. 100 animals, growth rate of 1.02%. So they've already given it to us, and they gave us this function right here. 100 times 1 plus 0.02 gives the population in years. Well, in how many years will the population first reach 300? So, guys, you have no choice here but to take the formula 100 times 1.02 to the x and try some numbers to see how long it takes you to get to 300. Okay? And so especially you guys with those yellow calculators, as you just take a number in here and you times 1.02 to the, I don't know, I'm just going to start with some number. I started with the number 5, thinking that after 5 years, wow, it's only at 110. So I got to just keep guessing and checking if you have one of those calculators. If you got one of these bigger, fancy TI calculators, you can go a little bit different and you can create a model out of this and put in 100 times 1.02 to the x, and instead of having to go through every single process, you guys with those yellow calculators, that's what you would have to do, is you just have to keep plugging the numbers in. I can look at this table here and I can see that it would take a long time for 100 deer to become 300. See, I'm up here at 70 or 30 years right there. So somewhere, guys, somewhere it looks like somewhere between year Come on, slow down. Somewhere up here between year, what was it, 50 or something like that. So somewhere between year 55 and 56. Because if you plug in a 55, as if I kept guessing and checking right there, it would take an awful long time to do this. But if I put a 55 in, I get the 297. If I put in 56, that's the first time that amount gets over 300. So the first reach 300 would be somewhere about 55 years. Okay, you guys, that's how these formulas work. You just plug the numbers in there, and it gives you the next successive year. And we talked about this yesterday. There were two situations that we talked about. What was it? We said if a set of data has a common difference, it's linear. If it has a common ratio, anybody? It's exponential. And then if it has, yesterday we looked at that one, because it asked on here, if it has a second difference, it's called a second difference. That's quite right. Well, like Stephen said, it's a second degree equation. So what we're looking for here, guys, and this is the same problem, that's where I got the problem from yesterday. Okay, which of these order factors satisfies an exponential equation? So it was, wasn't it, which one was it? Wasn't it, I thought it was D, wasn't it? No, B is 10 minus 6, 6 minus 2, 2 minus, that one's linear. That one's linear. This asks for an exponential equation. So the one that's exponential means it'll have a common ratio. So you do. Y'all says on your page it says linear. So it is linear. Okay. This is the. I must have printed y'all's off of the one that says linear right here. Okay. So this particular one says exponential right there. What I did was I copied the and I put the word linear in right there. The one that's up here says exponential. Y'all says linear, so the answer to y'all's would be B. The answer to what I have here would be D. Okay, here we go. Here's the first one that we have to do. It says annual sales for the clothing store are 680,000 and are increasing at a rate of 2%. Again, that's this formula right here. And the reason it's this formula right here, guys, and again, for those of you that are sitting out there not feeling good about this stuff, that's what it is that lets you know to use plus right there is what word right here? That's exactly right. When it says increasing, you know you're going to use 1 plus. So as soon as it says that word, it's 1 plus, and then 2%, talk to me. Very good. 2% is 0.02. So then you can plug it in, 680,000 times 1.02 to the 3 years to the third. So guys, then again, it's just a matter of plugging these numbers into your calculator, 680,000 times 1.02 to the third, and there you go. $721, $621. Guys, the rest of these at Kangaroo are decreasing at 0.2%. Your decimal is going to be 0.002. Keep going. I'm going to work this later. I'm going to put 2 of these up here. I want to move forward and go to one of these problems right here and then stop the video and then let you guys work some more. Okay? Y'all's on this one here, look, it has this. You guys had asked me if I would go to my web page and use this one. This is the one that's on yours. Okay, so I went and got that. So what I want to do right now is I want to do one of those using this. Okay, I want to use this problem, y equals 2 times 3 to the x, using this table right here. Okay, so here's the way you use this table. So the equation, guys, the equation is y equals 2 times 3 to the x. On the page that I had, it was a little table like this right here. You guys said this y equals 2 times 3 to the x was a little bit better table. And so I like that. I like that you guys asked for being able to do that. So the first thing you do is you set this up. Guys, write out on your paper, write why this stuff is here. This is where your equation goes. The equation goes right there. That's what it is that we're trying to graph. Then in this section right here, that's where the parent graph goes. Okay? And the way, guys, the way you get your parent graph is from, you take the equation, you look at the equation, and you write out this information here in these columns right here. So in this particular problem, h is 0, k is 0, and a is 2. Okay? And so now I come over here, and the first thing I want to calculate is my parent graph. And the reason this is the parent graph is because the exponent is with the number 3, and that's called the base. Everybody good? The multiplier is the number 2 that's out front, that's A. Then the number that's up here with this is H. Remember, we take the opposite of it. And the number sitting out here by itself is K. So I'm going to go through the process now, guys, and I'm going to use this table, and I'll put this table on the test for you so that you can use it, or at least give you a copy of this table so you can use this particular table. Okay. Again, this is what was on the regular sheet that I had. That's what was on and I changed it to this so that you could follow out how this goes. But it doesn't do us any good. We don't know where this stuff comes from. So guys, I take the number 0 right here, and I calculate y equals 3 to the 0. Guys, any number to the 0 power is 1. So I go 3 to the 0 is 1. So I get a 1 right there. So then I say y equals 3 to the first. And all I'm doing is I'm taking these numbers and plugging them right there for x. So what's that? Okay? And then I get 9 right here because it's y equals 3 squared. So that's 3, and then that's 9. And then here's the part that is kind of throwing me for a loop that we're not seeing. Guys, when I do -1, and I said this very word the other day, and then turned right around and asked you guys to do one of these, and somebody put 1/6 right there. Guys, don't do that. Look, get these numbers right here. Get this 3 and take the reciprocal of it, 1/3. Get this 9 and take the reciprocal of it, 1/9. Again, guys, that's how you do negative exponents. That's what negative exponents mean. Negative exponents means you take a number and you take the reciprocal of it. You have that button on your calculator. You guys use the calculator. You have a button on your calculator that says x to the -1. The reason it's there is so that you can take a calculator and you can calculate the inverse of something really quick, because that's what it does to us. So what the -2 does is it takes square it, turn the reciprocal of it. So 1/9. Now, guys, these exact numbers, right here, I rewrote right there. Guys, I just rewrote them over. Okay? And then these numbers right here are going right here in this column right here where y is. And I just rewrite those numbers over again. So that's 1/9, this is 1/3, this is 1, this is 3, this is 9. Okay, that's how you use this table. You take these numbers and put them right there. Now, what I did in this column was I went ahead and I added h. In this particular problem, h is 0. So I'm going to go -2 plus 0 is -2. -1 plus 0 is -1. 0 and 1 is 0 plus 0 is 0. 1 and 0 is 1. 2 and 0 is 2. So this says the transformed x values. And so you want to take your transformed x values and put them right there. So again, it's just a matter of copying them over again. All right. Now I'm going to do the same thing with my y values. But this time, guys, look, I'm going to do it a little different. I've kind of figured out as we use this thing, it's easiest in this column to go ahead and times it by 2. So when you do the A, you times that number by 2. So 2 times that, 2/3, 2, 6, and 18. So I times all those, in that column, I times those numbers by 2. Now, here's the one that seems to be throwing some people for a loop on how you use this table right here. Guys, write whatever it is over again. So write whatever that number is, write it over 5 times. So if that was 4, there would be a 4 down here, 5 times. So you can see, right in front of your eyes, you can see what it is that you're doing. And then in this column, you write where I multiplied it by A right there, so that's A times Y, and then add K and put it right here. So 2/9, 2/3, 2, 6, and 18. And that's the numbers I write here. So 2/9, 2/3, 2, 6, and 18. I just rewrite those numbers over there. Now, again, guys, I refer to you to Stephen's his blog that I showed you yesterday. If you remember, he didn't just take this picture and put there. It wasn't just this picture. It was this picture and an explanation of what that picture does, so that I know he's got a really good idea that the first thing that you want to do after you do your parent graph, but the first thing you do when you get to the graphing section, guys, is you want to graph your asymptote. And that's what it says. It says graph the asymptote. And again, it's always y equals k. So whatever number is right here underneath k, that's where you graph a horizontal line. Again, for those of you trying to kind of visualize, get in your mind where y equals is, that's what I showed you from Desmos here when I said y equals 0. If you remember, I graphed the other day, I graphed this y equals, instead of 0, I showed you the other day what any equation, guys, looks like when you make it y equals. Look, it's a horizontal line. So depending on where that horizontal line is, guys, you have a good idea where your line is going to be getting closer and closer and closer to. Now, the last thing is, look, this point right here, this -2 and 2/9. So here's -2 and 2/9. I get down that close to it. Then this point right here, -1, here's -1, 2/3 is going to be a little bit higher. Here is 0, 2. So I graph 0, 2. Okay, here's the next one. I graph 1, 6. So there's the point 1, 6. So here's the next one. I graph graph 1,6 is blue. Graph 218 is the point over 2, guys, up 18. Again, guys, what those 5 points do right there is they give me a good direction for graphing these lines right here. So I know. Look, it's not going to do that. I accidentally crossed my intercept. Guys, I don't want to accept that as the end. Right? You just erase it and fix the thing, guys. And if you got to graph these points again, I know there's negative 2/3, there's that, there's 0, 2, there's 1, 6, there's 218. So I'm going to try it again to get close to this line. And then, oh, now I kind of go through those lines. Guys, I fixed it. What some of you guys are doing when you mess up, you'll graph one of these, and you'll graph it down here, and it'll cross the asymptote like that right there. That's not right. You can't leave that. That looks like you don't know what you're graphing. This thing is, you worked it out, you graphed your T-chart, and you were coming down here, and all of a sudden you had a point out here, and you curve back up there. Okay? That's not right. Fix what it was that was your mistake. Figure out why this thing didn't continue on there as an exponential growth. You with me? Again, that's what some of us aren't doing, and that's what I'm frustrated about, is if y'all bring it down here and y'all go across the asymptote, we're just leaving it like that. That's what I think it looks like. Guys, you got to be conscientious about this stuff. But again, graph these points. As graph those points right there. That's what this stuff is about. That's how you graph an exponential equation. Excuse me. Is that how you graph a linear equation? No. When you graph a linear equation, you go to the y-intercept. The y-intercept, you go up and over the, you with me? That's different set of directions. Completely different set of directions. And guys, again, I can keep putting this stuff up here, and I can keep showing you all this right here, but you got to know what all that means. Look, over here, create the parent graph. Graph your asymptote, that horizontal line, and then boom, there you go.